Bismillah ar-Rahman ar-Rahim. This is the opening session for the ACLing 2029 to 2021 5th International Conference on AI in Computational Linguistics, which will start today and will continue till tomorrow, 4th June till 5th June. I would like to welcome everyone. And we have our chair, Professor Dr. Abdullah Shamsi, the Vice Chancellor of the British University in Dubai, who is the main support of this conference during the years, and he is going to give us talk regarding the opening. Please, Professor Abdullah, the floor is you.
Thank you, Professor Khalid, very much for your kind words. Actually, the conference has been an effort on everyone at the British University in Dubai, but a lot of effort has been put by yourself and the conference chairs as well, the other ones. So thank you very much. And let me start by welcoming everyone to this conference, which is being held virtually. It is the 5th conference on computational linguistics, and I'm so happy that the name has changed now to AI in computational linguistics, which gives it a very broad topic. The conference have moved now from being just Arabic linguistics to any language. In addition to that, it moved from being just a text, computational linguistics in terms of text, to video, images, text, everything else. So actually, the conference now is much wider, has much wider scope, and I am sure that this kind of conferences will continue for a long time to come. I wish you all the best and success in this conference and in the years to come. I'd like actually to thank everyone who contributed to this. Actually, the conference chairs, Professor Khalid Sha'lan and Professor Samha Al-Biltaji. Professor Khalid Sha'lan is a professor of computer science here at the British University in Dubai, and Professor Samha also from New Giza University, or as they pronounce it in Egypt, New Giza University. So thank you very much for all the effort put in for the conference. Also the other chairs, whether the program chairs and the local organizing committee, a lot of effort has been put into this. So thank you all very much for making this a reality. I have also to thank Professor Mona Diab from the United States, who will be offering or presenting the keynote speech for the conference. It's early morning there in the States. So thank you as well very much for that. Professor Mona is a very well-known researcher in the area of computational linguistics in George Washington University in the United States. So thank you very much. Wish you all, Professor Khalid, your team, everyone else, success. The conference proceeding now is a severe proceeding, which is great for everyone. It's a Scopus index, and all the luck and success for you. Thank you very much, Professor Khalid.
Thank you, Professor Abdullah. Professor Samha, please, can you give us something about the conference?
Okay, good morning, everyone. First of all, I'd like to welcome everyone to the conference. It's a real pleasure to see that the conference is now, this is the 5th edition. Just a little brief history about the conference. It started in 2015, and it was, at the time, it was co-located with ACLing. In 2015, ACLing was held in Cairo, and I was chair of the local organizing committee. And Professor Khalid and myself thought that it would be nice to have a conference on Arabic computational linguistics. The first conference was published as in IEEE, but since we've taken it to Dubai and with the support of Dr. Abdullah Shamsi, we have been able to actually get it into Elsevier as procedure computer science, which, as you all know, is much more prestigious than it is one of the most prestigious proceedings we can dream of. I'd also like to congratulate everyone here for actually getting a paper in the conference. This year it was very competitive. We had about 100 plus submissions, and our acceptance rate was 47%. I think Dr. Khalid is going to mention something about this in a minute. And so this has been our lowest acceptance rate so far, and we hope that in years to come it will become more and more competitive. Later in the evening, Dr. Mona Diab is going to be giving a keynote speech, and I'm looking forward to seeing you all there. I will leave the floor to Dr. Khalid, who is going to talk a little bit in details about the conference, this year's conference. But at the end, I'd like to extend my thanks to Dr. Abdullah Shamsi for all his support, and we look forward to further successful editions of the conference. As Dr. Shamsi has mentioned, we have changed the name of the conference. It's now AI in Computational Linguistics, because we thought that it would be much better to broaden the scope of the conference. And I think that we've been able to attract a larger audience this way. Thank you very much, and I'll leave the floor to Dr. Khalid.
Thank you very much. And we have Professor Khalid Al-Marri, the Dean of Research in the British University in Dubai. And I give also the floor to him to comment on our efforts and share us in this panel session. Please, Professor Khalid.
Thank you, Professor Khalid. Hello, everybody. Welcome to this edition of ACLing. I would like to thank the organizing committee, the chairs, for bringing this back. It's been a while since the last conference because of COVID. It's great that you're bringing it back and much stronger than it was before. I think it was more than a year and a half ago. It was a successful one, no doubt about it. But this one, since the theme was changed a little bit away from the Arabic linguistics, I think it opened a more area for participation and encouraged others to submit their publications. There were very good publications in the past, and it's great now to see that it is Scopus indexed. It is a great opportunity for our students and our faculties to participate in this conference. It's always great to see it growing stronger. I wish everyone great success in this conference, and I'm looking forward to attending some of the sessions that I'm sure will bring some light on emerging themes that are happening in the past year or so. Good luck to everybody.
Thank you very much. I am going to give just a brief about the conference. I prepared just a few slides about it. The motivation or the idea of the conference came from the field of computational linguistics and natural language processing. We thought that bringing all the academics and science research and practitioners from over the world will help exchange new ideas, share results, create connection, and share resources. From the years when we started 2015 till 2016, 17, and 18, we keep growing, and we have also very good relationships and cooperations from colleagues, either with us or with themselves. We hope this also to continue, and we provide also during the conference rooms for meetings and for networking. These efforts has been done and it is equally contributed, and a very balanced teamwork between Professor Samha and myself. Hence the idea of starting this. We started with IEEE Explore for the first two conference. Then we switched to, this is the third time we are publishing with Procedure. Procedure is by Elsevier. It's ranked, it's open access. It's costly, but we give thanks for the kind contribution from the British University, which supports us to at the very beginning, and will continue to find the high quality venue for adding your quality paper in it. We have prepared a Google page or a Google citation for the conference. So these are all the conference papers along the years. It's till today's it is HN2 is 19, and we have 1,397 citation. So your work, as this is evidence that your work is cited, your work is recognized, and inshallah after we publish this year, your work gets more visibility and more cited. These are some statistics from the conference submissions to the ACLing. It was from 28 countries, different countries. These are the countries from each year. And we received 101 submissions. 47 were selected for publication, and they are from 24 different countries. The acceptance rate, as we promised, we are going toward the standard by accepting lower number of papers. But at the beginning, when we started, we are very flexible. Since we started with ACLing, and with the conversation with Alexander during ACLing, he told us about what we are going to face, and gradually we are approaching the standard. So in 2018, our acceptance rate was 74. In 2021, our acceptance rate is 470, and with more submission, with more serious review. We review the papers are reviewed by people who are reputed in the field, and we don't interfere. We accept the paper that really deserve to be accepted, and we use the facility from the British University for plagiarism detection. So all the papers are checked for plagiarism, and any warning or flag are conveyed to the authors, such that we don't have any issue or problems in terms of plagiarism with our papers. In terms of reviews, we have 247 reviews for the 101 papers. We have papers that are very few by 1 reviews, then 43 by 2 reviewers, 3 by 44, and 4 reviews for 5 papers. And all of them we didn't interfere, we didn't assign. It's already assigned by the system according to the auction and according to the preference of the reviewers. We would like to thank many, and on top of this list is a Professor Abdullah Shamsi, the Vice Chancellor of the British University in Dubai, for his trust, confidence in the conference organization, and also for financially supporting the conference, which is very important for an infant conference to sustain and start. We would like to thank Professor Khalid Al-Mirri, the Dean of Research in the University in Dubai, for his support and guidance, and also for putting the plan and the organization of this conference. We would like to thank the Dean of Faculty of Research, of Faculty of Engineering and IT, Professor Bassam Abu Hijla, for the support and the help from the idea till now. And we would like to thank the invite speaker, Professor Mona Diab, who is pioneer in this field, for her valuable contribution to the conference. We would like also to support to thank the authors for their research efforts in conducting high quality research and submitting it as article to ACLing. We would like to extend our thanks and appreciation to reviewers for the time and efforts they have put voluntarily in writing constructive comments and feedback. Last but not least, we would like to thank the ACLing team at BUIT for dedication and professionalism. I would like to thank Mr. Ahmed Muhammad, the accountant, Mr. Joe for the marketing, the social media appearance, and Mr. Khalil for the IT services, and Mr. Abdullah Nukreti, who is helping us in the conference, and he will be there at the chat rooms for anyone who would like to get any support. This is part of the long list from the British University. And also I would like to thank Professor Samha Beltagi from the New Giza, and the president, and all the colleagues in New Giza and before them in Nile University, who contributed to this conference and still give us support. There is visible and invisible efforts that you can feel unless you are organizing a conference. For the conference, the last years, it was really equally, because it distributed between me and Dr. Samha. But since this is virtual conference, the part of organizing the conference at the host is not there. So this means that Dr. Samha is much appreciated than me, and she did a very good efforts, and I would like to really thank her for her dedication and time, and we wish to continue this event and other events in the future, inshallah. Thank you very much. And after this, according to the, as you know, we are following the GMT time because of the differences, and since we are not in the Arab region, we have people from all over the world, so we choose GMT, which is closely related to the majority, and we are going to, after this, to have a break. Then we will start the first session, which I'm going to chair. Then we will go into parallel sessions, that each session is chaired either by Professor Samha or by myself. You will enjoy the papers because they are carefully selected, and also the authors are good names, either the first author or the co-authors. So we wish everyone the good luck. Thank you very much. Please attend all the sessions, and we need your contribution. We need your comment during and after the conference. Thank you very much. Dr. Samha.
Okay, I think that in about 10 minutes, we're going to start the first session that will be chaired by Dr. Khalid. Just a few comments. If you would like to ask a question, you can either write it in the chat during the presentation, or at the end of the talk, you can please raise your hand. I'd like to ask everyone to please mute their mics, and they should raise their hands if they want to. There is a raise hand facility I think everyone is familiar with in Zoom, and Dr. Khalid will select the person that is going to talk. We have 6 breakout rooms. We haven't opened them yet. They're going to be opened after the first session. 2 of those breakout rooms are they're named Hall 1 and Hall 2, and they map directly to the conference program. So you can either go into Hall 1 or Hall 2 depending on which presentation you're interested in. The other 4 are another 2 rooms are for discussing papers that were presented in Hall 1 and Hall 2. So they're named Discussion Room 1 for presentations that were presented in Hall 1, and Discussion Room 2 for presentations that were presented in Hall 2. And then there's a networking and socialization breakout room. Anyone can join this breakout room, and it's more of an informal place where people can talk to each other. And there's also a meeting room. This is sort of a private room, so if 2 or more people want to get together, they can use the meeting room. It's going to be very easy for you to navigate through the breakout rooms once they become available. If you're using Zoom for desktop, then your control panel will show something called breakout rooms in the control panel itself. If you're using a mobile device, you'll get an icon for breakout rooms on the top left corner of your mobile device if you hover using the mouse. And of course, both Dr. Khalid and I are here to answer any questions. And this was just a point of organization that I wanted to mention.
Please note that also that each presentation is 20 minutes. So try to give just 5 minutes for discussion, and we have to switch to the next one because we are strict on time, especially in parallel session, because in parallel session sometimes people are selective and they go from hall to hall to pick some papers. So please try to stick into your time, because I didn't want myself or Dr. Samha to stop you in your presentation. So plan well for your presentation, not to exceed that 20 minutes, giving at least 5 minutes for discussion. Thank you very much.
If there are any questions, we can answer them because I think we have about 7 minutes. So if anyone has any questions, I think Dr. Khalid and I. And by the way, I probably got the message, but the opening, this opening session, as well as the first session, are being live streamed on YouTube right now, and I sent the link to everyone in the chat box.
Thank you. Professor Abdullah, thank you, and give us a blessing to start the sessions.
Thank you for this full information. It's really very interesting to hear all of that. And good luck. You will have the first session in a few minutes' time. Good luck, all of you. Wish you all the best of luck and success.
Thank you. Thank you.
Professor Khalid, you and Professor Samha are not in the last slide of the thank you notes. So I would like to thank you both for organizing this conference. I should say it is the least strain on our side. It is really well organized. There's really almost nothing that we did from our side. It seems like there's a good chemistry. We've been organizing this with great success. Really, we're very appreciative of your efforts. And I would like to thank the VC as well for just allowing all the resources on the spot in such a short time to support this conference. And really, these are great efforts. And I really appreciate all of these efforts from all of you.
Yeah, thank you very much, Dr. Khaled. Much appreciated. Thank you.
Bismillah ar-Rahman ar-Rahim. We will start the first session, which is session 1, and it is from it's from now, I think, and it's about sentiment analysis. And we have 4 papers. The first one is deceptive opinions detecting using new proposed Arabic semantic features by Amal Ziani from Algeria. She's a presenter. She told me today she has some problem in connection, but she will try to present it. And the second one is a combination of query extension, ranking, and GA-SVM for improving Indonesian semantic classification performance by Long Hendro Rostio. And the third one is sentiment classification with fastText embedding and deep learning model by Isniani Neuro. And the last one is suicidal risk identification in social media by Ashok Kumar Jha. So if the first one is there, Amal.
There are no participants with the name of Amal, so either she hasn't joined yet.
Amal Ziani. I already she sent me her video, but I don't know because she said she might have some problems in connection.
Amal Ziani, she has problem with her connection. I'm her colleague.
Okay.
There's some technical issues.
So shall I present her video?
Yes, please. If you could present her video, it will be better because she has some technical issues with internet. Every Friday here in Algeria, we have some technical issues with internet.
That's what she told me.
Yes.
Okay. So this is deceptive opinion detection using new proposed Arabic semantic features by Amal Ziani.
And Dr. Shahab and me is Mr. Jamal Zinakha, Al-Adwani, and Shikai, Miss Zamal, and Mr. Haj Saleh.
Okay.
Those
so
are our colleagues.
So after the presentation, please, if there is a question, you can answer. Is it okay?
Okay, thank you very much.
Most welcome.
Assalamu alaikum. Hello everyone. I am Dr. Amaziani from Algerian University, and I am here to present you my work, which consists on Deceptive's opinions detection using new proposed Arabic semantic features. So, the Web 2.0 has emerged with more interactive spaces such as social networks, blogs, and forums. Recommender systems were introduced to help the public adjust to these changes. A recommender system helps users who do not have enough experience or skills to assess the potentially large number of alternatives offered by a website. In their simplest form, the recommender system recommends personalized lists and classified articles to their users, provide consumers with information to help them decide which item to buy. Articles can be music, books, films, hotels, cars, products, food, and other stuff. So, traditional methods of collaborative filtering focus on the people's vote and ignore the comments, which make the comparison with other users risky, because sometimes users do not express their opinions explicitly with votes, but they only leave comments. Analyzing these kind of opinions has become an important task in our recommendation system. So the question that arises, can we improve the quality of recommendations by analyzing the comments and opinions of others? Opinion mining or sentiment analysis is a challenging task that combines data mining and natural language processing techniques in order to computationally treat subjectivity in textual documents. And we can say also that the sentiment is a thought, a view, or attitude, especially and mainly based on emotion instead of reason. So it is important to detect or to classify a text, an opinion text, and a review text. So the purpose of the opinion classification process is to assign a label to the text according to the opinion it expresses, generally considering the classes positive or negative. The process of researching opinions or analyzing sentiments or exploring these opinions goes through 4 stages: data acquisition and pre-processing. Any sentiment analysis application requires a data set to learn a classifier, or to be more exact, to train the classifier and to test it at the end. So there are some corpuses in Arabic, but unfortunately not all of them are available, and we don't know the reason why. So the extraction of features is a very important task for the classification of opinions. Representing a common text by a features vector is the basic step in any supervised learning opinion classification approach. There are several types of features used in opinion mining: lexical, semantic, or vectorial. So, for the last phase, which is the classification phase, there are several techniques that have been proved in the opinion mining area, in the Arabic language especially. So, like supervised learning, semi-supervised, deep learning, etc. So, after a deep analysis of the collected opinions from social media, we noticed that positive opinions often mean profits and glories for businesses and internet users, which unfortunately that strongly motivates people to deceive online systems by posting false opinions or criticism spams. Therefore, our objective is to eliminate spam opinions before starting the recommendation. For this reason, we are trying to find a better representation of spam opinions by exploring new semantic features. So, Here is our proposed deceptive opinions detection system that goes through several phases: data acquisition and automatic pre-processing, then the extraction of lexical features for use it in the semantic features extraction phase in order to merge the two vectors for the final review classification task with the ACLing. We will detail all these steps in the following. So, as we mentioned before, there is no proper Arabic language dataset for our experiments that offers well-structured reviews. When we say well-structured reviews, I mean a full text with no spaces and emoticons and that contains a lot of relations. So a well-structured Arabic text. Thus, and after having analyzed the reviews in ACL dataset in English language, we noticed that they have generated considerable number of structured opinions, 1,600 reviews through our deceptives, which motivated us to translate them into Arabic to build a dataset for our experiments. We use this solution to compensate for the lack of resources in Arabic and to use meaningful structured texts. So, at the end of our deep analysis through the bibliographical study of existing works, we underlined the importance of discourse parsing and the dependency relations in opinion mining, where the general meaning of an opinion text or its polarity can be affected by the existence of a dependency relation. It can therefore strengthen or contradicted. As the following example explains: أنا أحببت جدا المقال لأنه وصف المعبرات. So the second use explains the first. It means that it reinforces the positivity of the first use. Since the polarity of the second elementary discourse unit is positive, it reinforces the polarity of the first use due to the explanation relation that connects these two ideas. We can conclude from the tree that from this example that the relation polarity score can affect the general sentence polarity score, which can be positive or negative or neutral. Having decided on all the units and the root of the tree, we can build the tree and assign for each node two parameters: the class and the polarity score, where these two parameters will be calculated in the second step. Using these structured units, we can build the tree where each edu is represented by a leaf in the tree. For each two connected edus, there is a parent node of the two leaves containing the connector. To decide which node is the root of the tree, we follow an algorithm that uses the priority of relations. Priority criteria have been defined previously in our algorithms after throughout analysis of Arabic connectors, where some of these relations have more importance than others in the discourse. So therefore we can come up with a new set of features that represent better the opinion test. Thus our proposition is based on dependency relations, as we have mentioned before, of course. So, nevertheless, it is practically very difficult to recognize deceptive reviews effectively by reading them manually. Considering that spammers can post deceptive reviews similar to real reviews, despite these difficulties, several supervised learning algorithms can have been proposed and evaluated for the deception detection task. But only a few datasets are available and provide deceptive and truthful comments. So we proposed to use a semi-supervised technique ACLing in order to overcome the lack of the annotated data. Now, to train and test this semi-supervised classifier, we need an efficient representation of opinion texts. Therefore, we used the two sets of the proposed features, lexical and semantic, as shown in the table. So, in order to assess the performance of the proposed features, we conducted a first experiment on spam detection, the spam dataset of 1,600 labeled reviews and in Arabic, and 1,400 unlabeled reviews. So the test phase was applied to 400 labeled reviews, or 200 of them are true and the rest are spam. So on the basis of the experimental results obtained from experiment A, we can conclude that the proposed features have been shown to be very effective in the detection of spam opinions in Arabic by an accuracy of 93%, taking into account the difficulty of the detection of the deception even for human beings. So, to compare the results with other experiments, we have conducted other experiment B on polarity detection, where we obtained an accuracy of 89.48%. So, at the end, we compare the results of the two experiments with other polarity and spam detection work in order to prove that our proposed features have been shown to be very effective in analyzing opinions in Arabic and detection deception. So, surpassing the results obtained by statistical features that have been evaluated in previous work. This study presented a basic tool which can be used to detect deceptive opinions to feed a recommender system in order to obtain the best results using the new proposed semantic features. So, the enhancement made on the proposed approach allowed us to increase the accuracy of the system. There are different directions for extending this system. On one hand, we could improve the Arabic dataset by constructing an annotation system based on an active learning technique. On the other hand, it would be worthwhile to profit from vectorial representation and other perspectives. So, thank you for your attention. Any questions are welcome.
I can't. I can't.
Mr. Sha'lan, we can't hear you. We are not hearing anything, Mr. Sha'lan.
Hello.
Sir, you're on mute.
Yes.
Khalid, unmuted.
Okay. Because the control is not with me. Dear Amal, would you like to answer questions?
Yes, of course. Now I can.
Okay.
Thank you.
So, any questions?
I'd like to ask one. I can't see anyone who's raised their hands, so allow me to ask a couple of questions. First of all, let me congratulate you on the good work. But my question to you is, you know, in the last couple of years, the trend has moved towards using deep learning, and alternative features are no longer one of the things that are usually considered, because it's, you know, one of the advantages that of deep learning is somehow it's claimed that they do this for you. So my question is, why haven't you investigated the use of deep learning in your work?
Thank you. Actually, the use of deep learning is clear that that is an advantage for any system. But actually, when we work on Arabic NLP, Arabic, we treat a lot of Algerian dialects and Arabic Amasa and everything. So when we tried, actually, there is we conducted an experiment about using deep learning on our data sets, but we couldn't have the same rates as the other features and other techniques. We can explain that by that deep learning doesn't work well with small data sets. So as we all know that Algerian dialects and Arabic Amasa and data sets that are in specific topics like sports or products or we can say that is unavailability of such data sets in the internet. So we thought that if we ameliorate the features and ameliorate the phases of extraction features and the classification using the classical techniques like supervised and others, we can profit from the text, the Arabic text, and we can apply all this on the dialects of Algeria.
But the small data set problem has been addressed before through using transfer learning, something that has been trained on a huge data set of multiple dialects. And this has worked in maybe, I haven't seen it in Deceptive opinions, but I've seen it in other sentiment analysis, Arabic sentiment analysis for multiple dialects, and it's worked very well. So I would recommend, if you would accept my recommendation, to try an approach like that. And even if it doesn't yield the results that you expected it would yield, it would be interesting to see the results of your system side by side to what a deep learning system would have performed. That's my recommendation anyway. If you would.
Thank you. I will consider it. Thank you.
Okay, thank you very much. I think we will move to the next presentation, which is a combination of query expansion ranking and GA-SVM for improving Indonesian sentiment classification performance. Dr. Burung, are you available?
Yes, sir. Yes, Bob.
Would you like me to upload your video, or you are going to do it live?
Yes, I have upload my video on your email.
Okay.
I prefer to play pre-record because I think my connection is not enough, not good.
Okay. Okay.
Assalamualaikum warahmatullahi wabarakatuh, and good afternoon in Indonesian time. First, I want to introduce myself. My name is Purnahan Prasetyo. I am from Indonesia, Kejiman University, and Department of Electrical Engineering and Information Technology. Today, I want to present my paper entitled Combination of Query Expansion Ranking and Genetic Supervector Machine for Improving Indonesian Sentiment Classification Performance at International Conference on AI in Computational Linguistics, the British University in Dubai. Background: we know sentiment analysis is the best approach to classify people's opinion quickly. Sentiment analysis has two approaches: machine learning based and lexicon based. Here, machine learning is better than lexicon, but has some problems, such as high dimensionality of feature pairs, noisy features, So we need feature selection to tackle this problem. Because why? Because feature selection can reduce the dimensionality of features, can select valuable features, and can decrease computational time. Feature selection, in common, feature selection has two approaches: filter-based and wrapper-based. For filter for advantages in filters, simples, independent from classifier, and low computational time. For disadvantages, there are still noisy features included in the classifier. In filter, query expansion ranking is a new algorithm in filter-based. Query expansion ranking has a good performance. It's better performance than filter methods such as information gain, G-square, DFD, and etc. For the wrapper for advantages, wrapper has a good performance, but for the disadvantages, wrapper is complex and has a high computational time. In wrapper, genetic algorithm has a simple methods and good performance. In this study, we wanna try to combine two algorithms, query expansion ranking and genetic algorithm. We hope the combination of them can overcome the shortcomings of the wrapper method by taking advantages of the filter method. So that research objective, this study aims to develop new feature selection method by combining query expansion ranking and genetic algorithm to improve sentiment classification performance. Related words, feature selection method is an important stage in machine learning-based sentiment classification because it can solve high dimensionality of feature space and noisy features. Some feature selection methods have been developed by researchers for sentiment classification domain, but filter-based and wrapper-based method. First, in 2018, G-square proposed by some researchers. Next, query expansion ranking proposed by Parler et al. In 2018, and genetic algorithm proposed by a researcher in 2018, and then iterative greedy heuristic proposed by researchers in 2020. In 2021, we proposed query expansion ranking and genetic algorithm superfraction scene. Research methodology for a data set. We took Twitter data about the omnibus law policy in Indonesia because it has become a hot issue. We obtained 40,097 tweets on Twitter using the Get All Tweets Tree library. In the study, hashtag omnibus law and omnibus law were used as keywords. After that, duplicate and unseen data were eliminated. We used 4,000 label tweets for the training process, where 2,000 of them were categorized as positive sentiment and the other 2,000 tweets were negative. For preprocessing, we use case folding, filtering, slang word, stemming, tokenization. In the filter extraction stage, we use TF-IDF to convert text to vectors. And in for filter selection, of course, we propose a combination of query expansion ranking and genetic algorithm super vector machine. And then we compare with baseline algorithm without filter selection, query expansion ranking, and genetic algorithm itself. For the classification stage, we use super vector machine to classify all sentiments quickly. And for the validation and evaluation, we use conversion metrics, recall, precision, F-measure, and area under proof. Area under proof, we use area under proof to know whether the proposed method is excellent classification or bad classification. For validation, we use five-fold cross validation. For validation, we use five-fold cross validation to validate our proposed method. And next, we use t-test prior to sample for means to verify whether there is significant difference between the proposed method and the baseline algorithm. The combination of query expansion and genetic algorithm super vector machine. First, we load dataset.csv format. And after that, in the feature extraction, we use tf-idf to convert text to vector. And initial selection in filter method, we use query expansion ranking. Query expansion ranking is used to reduce and select the best feature in the initial selection. And we save selected feature from query expansion ranking in the file the best feature .npz format. What is npz format? npz format is sparse matrix, sparse matrix, and times n matrix, and features and data. Feature, of course, from the selected feature from query expansion ranking. Selected feature from query expansion ranking, we save in JSON format, and data is tweet. That data are tweets. Selected feature from query expansion ranking is an input in genetic algorithm to get optimized feature. This is all process from genetic algorithm super vector machine. This is a way we divide dataset to form training data and testing data, and we select the feature subset. We use optimized SVM. Why we call optimized SVM? Because SVM has challenging in the in determining optimal parameter. So we use grid search optimization to select the optimal parameter in SVM. So we call optimized super vector machine. And then the function of SVM here to get F measure value. F measure value is an input in the fitness of genetic algorithm. This is after that optimized SVM, we calculate the model F measure, and we calculate the F measure average, and we calculate the fitness, stratify stopping criteria. Now we run genetic algorithm process, starting parent selection, crossover, mutation, and generating population. And run stratify stopping criteria. If yes, we got optimized feature. Optimized features will be used in machine learning stage. For the simple simulation of the proposed method, this is a just example. This is a query expansion ranking stage selected by query expansion ranking. This is a feature. This is feature. The blue ones are removed because the blue ones have low scores. And after that, the remaining features optimized by genetic algorithm, and the blue ones are removed by genetic algorithm, and just 3 features left. Still 3 features. These features provide impact good are used in machine learning stage. This is just example simulation. And for the result and discussion, firstly, we compare the sentiment classification results of the proposed method, query expansion ranking, and genetic algorithm super vector machine with the baseline algorithm without feature selection, query expansion ranking, and genetic algorithm itself. Figure 1 revealed that the proposed method outperformed all state-of-the-art algorithm. The difference in the value of precision, recall, F measure, and area under curve were 1.68%, 1.67%, and 1.67%, and 0.23% respectively, again the baseline algorithm. The proposed method achieved better performance than the previous studies, including genetic algorithm and query expansion ranking, which obtained excellent performance compared to information gain, T-squared, DFD, and OGFS. Moreover, the area under curve score of the proposed method was classified as excellent classification. Secondly, we also compare the computational time of baseline algorithm with feature selection methods. For data testing using selected feature, the proposed method required 25.4 seconds faster than baseline algorithm, 7.89 seconds faster than query expansion ranking, and 2.47 seconds faster than query expansion ranking. This is this is genetic algorithm, sorry. 7.89 seconds faster than query expansion ranking and 2.47 seconds faster than genetic algorithm. It indicates that our proposed method can not only improve sentiment classification performance, but also can decrease computational time. The result can be seen in table 1. This is the proposed method. Computational time of proposed method is 6.35 seconds. Lastly, we employ a statistical t-test prior to sample for means to verify whether there is a significant difference between the proposed method and the baseline algorithm. In the study, we set the statistical significant level alpha to 0.05. It implied that there is statistically significant difference if the p-value is less than 0.05. Table 2 shows that our proposed method can significantly improve the sentiment classification performance with the proposed method obtained p-value of 0.0001. Its mean p-value is less than 0.05. Conclusion, this study has presented a novel feature selection using combination of query expansion ranking and genetic algorithm super vector machine. Based on the experimental results, our proposed method should significantly improve the sentiment classification performance. The proposed method outperforms all state-of-the-art method by achieving the precision, recall, and measure value of 96.78%, 96.76%, and 96.75% respectively. The obtained area under group score in the study was 98.66%, which means that proposed method was classified as excellent classification. Moreover, the proposed method should also decrease the computational time from the baseline algorithm. In short, robust performance are the most significant finding to emerge from this study. For FeatureWorks, researchers can try new combination of other filter and wrapper method to achieve different results. Moreover, researchers should use more experiment in determining the optimal parameter of genetic algorithm. I think it's enough for me. Thank you very much for the attention.
Thank you very much. And thank you very much. And this is the time for discussion. So, and we have enough time for discussion because we finished early for the first one and finished early for the second one. So,
Dr. Khaled, I see that Amal Ziani has her hands up. She has raised her hand.
So please, Amal,
Thank you. Yes, I would like to say something to the author. It would be interesting to compare his results with a previous work of mine where I used random subspace, genetic algorithm, and SVM. I used the same idea, the same process with random subspace. I think it would be interesting to compare our results and to see who's better with results. That's it. Thank you.
Perhaps the two of you can meet in the discussion hall at and see how maybe this could be some sort of a collaboration.
Yes, actually during conferences, when we could join ideas, we came with research for publication. Why not you discuss and we try to have a joint research together? That would be fine. Yes, Dr. Samhat, you have a question? Okay. So the others? Dr. Ulung, would you like to comment or to add something about challenges that you faced or about something that you don't have enough time to present in your presentation?
Sorry, Prof.
Would you like to add something?
I think it's enough for
Because
me.
we have time. Would you like to add something?
I think it's enough for me. I think
Okay.
it's clear.
Okay, thank you very much.
Thank you.
Thank you. We have the third one, which is semantic classification use fastText embedding and deep learning model by Ishniani Nuru.
Yes, Prof. Yes.
Okay. So would you like to present, or you would like me to upload your video?
Maybe my pre-record video.
Okay. Okay. Better for the connection.
Thank you.
Most welcome. Okay.
Hello. Good afternoon. Please introduce. My name is Isnainin Hasana. Here I want to present my paper, Sentiment Classification using fastText Embedding and Deep Learning Model. First, for the introduction, sentiment classification is one of the natural language processing tasks widely used in various industries. For example, in the movie industry, we can classify a movie review's sentiment polarity, whether it is positive or negative review. There are several approaches for classifying sentiment, such as traditional machine learning and deep learning. In several research, deep learning for sentiment classification can provide a better performance compared to the traditional machine learning methods. In recent years, the technological advance allowed deep learning models to have a complex architecture, which resulting in more computation time. Meanwhile, in a real-time application, an efficient computation time is required. In 2020, Hamid and Garcia Sapirain proposed a simple deep learning architecture for sentiment classification problems using a single-layered BLSTM model with glove embedding. They saw that the proposed model gives competitive results compared to model with more complex architecture. This research aimed to offer another simple model architecture to handle sentiment classification problem with deep learning and word embedding. First, we propose a single-layered BGRU model with fastText embedding. Second, we propose a single-layered convolutional neural network with fastText embedding. This study also compared the baseline model, which is glove and BLSTM, with fastText and BLSTM. Here is some previous study about deep learning approach for sentiment classification. Ouyang et al. In 2015 combined word-to-fact with CNN for sentiment analysis. They provide good performance compared to the RNN method. Liao et al. In 2017 used CNN for Twitter sentiment analysis because of its ability to extract information globally. This research proved that CNN can outperform the SVM and knife-based method for the sentiment classification of Twitter. Hassan and Mahmoud in 2018 combined CNN and RNN to capture long-term dependencies. Zhang and Rao in 2020 introduced the NBLSTM model for sentiment classification. They use N-gram to extract features and BLSTM for classification. The proposed model is able to outperform LSTM and BLSTM. Ma et al. In 2020 combined several deep learning models. They proposed an improved BLSTM CNN model for sentiment classification. Hamid and Garcia-Sapirine in 2020 proposed a single-layered BLSTM model for sentiment classification by considering computational problems. These models are compared to other models that have a more complex architecture and can provide a competitive result. And here is some previous study about word embedding. In this study, we use fastText embedding. fastText embedding was introduced by Mikhailov et al. In 2018. They modified the word-to-fact pipeline and was able to improve the quality of the word vector produced. They compared the use of glove embedding and fastText embedding in the word analogy, rare words, and squad dataset, and showed an increased performance when using fastText embedding. Young et al. In 2018 showed that using the right word embedding model can improve the CNN model's performance for text classification. In this study, we propose two approaches. The first one is the BGRU model with fastText embedding. In the architecture, the first layer is the input layer. In input layer, we already converted the text input into a combination of index. The second layer is the embedding layer. Here we use 300-dimensional fastText embedding. And then it will be followed by BGRU layer. BGRU consists of forward GRU and reverse GRU. The forward GRU processes the information from front to back, while the backward GRU will process the information from back to front. And the output of the BGRU layer will be the concatenation of the last hidden state of the forward GRU and the last hidden state of backward GRU. And then it will be followed by global max pooling and global average pooling. The global max pooling will take the max value, and the global average pooling will take the average. And then the concatenate layer will merge the global max pooling and global average layer into a single layer. And the last one is the output layer. Here's what happened inside a get recurring unit or GRU. Inside a get recurring unit, we have a reset gate and update gate. The reset gate is used to decide how much past information to forget. Here, we apply the sigmoid function to the input attempt step t that is multiplied by its own weight, and hidden state from the previous time step that is multiplied by its own weight. The sigmoid function will squash the result between 0 and 1. The closer to 0 means to forget, and the closer to 1 means to keep. Then, the update gate will filter the information from the past that we want to keep. The formula from the update gate is the same as the reset gate. The difference here is the weight parameter. The second approach we propose is the CNN model with fastText embedding. And here is the architecture of the model. The first layer is the input layer, then followed by embedding layer, Same as before. Here we use 300-dimensional fastText embedding. And then it's followed by convolutional layer. Here we use filter size of 300 and kernel size of 2. And then it will also followed by global max pooling and global average pooling. And merge the global max pooling and global average pooling into single layer in concatenate layer. And then the last one is the output layer. In this experiment, we use two datasets. The first one is movie review dataset. The second one is Stanford sentiment ribbon dataset. Both datasets contain movie review data and its class, which is positive or negative. And this is the characteristic of each dataset. The MR dataset has the size over 10,000 review with max length of 50 and average length of 18. While the SST2 dataset has the size over 9,000 review and max length of 50 and average length of 70. Both of the datasets have two classes, which is positive or negative. Here is the data processing we use in this experiment. First, we have raw data, which is the review text, and then it will go to pre-processing step, which include remove punctuation, remove stop word, and lowercase the text. And after that, we will count unique words in the dataset and make a dictionary. And then we will assign index for every unique word. And then we will represent each review text as a combination of unique index. The baseline model used in this study is a single-layered BLSTM model that proposed by Hamid and Garcia-Sapirain in 2020. The model used 300-dimensional glove embedding and a BLSTM layer. The baseline model architecture consists of an input layer, an embedding layer, a BLSTM layer, and then a global max pooling and global average pooling, and then concatenate layer, and the last one is the output layer. For the hyperparameter setting, we use the same hyperparameter setting as the baseline model proposed by Hamid and Garcia-Sapirain in 2020. For the addition, here, for CNN kernel size, we use 2, and CNN filter size, we use 300, and CNN activation, we use ReLU for both datasets. In this study, the model evaluation will be carried out using the F1 score matrix, precision, recall, and accuracy. Here's the formula for precision, recall, accuracy, and F1 score, where TP is the true positive, TN is the true negative, FP is the false positive, and Fn is the false negative. Here is our experiment's result. The first one is the result on MR dataset. The experiment on the MR dataset showed that the proposed model is able to outperform the baseline model performance. The result indicates that CNN can provide competitive performance compared to the BLSTM and BGRU model. These results also show that the effect of fastText embedding on the performance of the BLSTM model. The F1 score of the BLSTM model is able to increase to 79% compared to the baseline model that used glove embedding. Although BGRU requires fewer parameters to be optimized than BLSTM, BGRU can provide a competitive performance. Here is the result on SST2 dataset. The best result on SST2 dataset are also produced by the fastText and CNN model with 83.8% of F1 score. This shows that although CNN only processes information in one direction, the resulting performance was still competitive compared to the baseline model and the BGRU model. The use of fastText embedding to represent the review text on SST2 dataset can also improve the model's performance. This can be seen in the improved F1 score, precision, recall, and accuracy result in the fastText and BLSTM model when compared to the baseline model that used glove embedding. From the conclusion, the adoption of pre-trained fastText embedding as word representation on the MR and SST2 dataset can slightly improve the performance of the single-layered BLSTM model. One of the reasons is that the pre-trained fastText embedding is trained by combining position-dependent feature, phrase representation, and subword information, so fastText can handle out-of-vocabulary and rare words. The BGRU model can provide competitive results compared to the BLSTM model. The combination of fastText embedding and BGRU can present competitive performance compared to the baseline model. The sentiment classification using the CNN model can give competitive results compared to the BLSTM and BGRU model. CNN is able to train the model faster than the two methods because CNN is computationally more efficient. Apart from that, convolution itself has sparse connectivity and parameter sharing. So it can be concluded this study is able to produce a model with a simple architecture for sentiment classification problem, but still provides competitive performance. And thank you for your attention.
Thank you very much. And Dr. Eshniani, I think you are available for questions.
Yes, Professor.
Thank you very much. Very nice presentation. So if there are any questions from audience? It's better that you, all of you are researcher and all of you have very good background about language processing and machine learning. And actually, I think you might have questions. So who is going to start?
Can I ask a question, Professor Khalid?
Yes, Professor Ashraf Al-Naggar is one of the, he is my friend, and he is one of the top researcher in Arabic and machine learning.
Thank you, thank you, thank you. Well, I mean, the topic is very interesting, but I wonder why you did not use attention-based models for your deep learning, because attention-based models are proven to give better results. One more argument in the view of contextualized word embeddings now, people are moving away from classical word-to-vec, fastText, glove into BERT-based models. Why didn't you consider that as an embedding layer in your deep learning model? Thank you.
Thank you for the question, Professor. I think that's an open problem, and I think that's it's open to everyone to do research using BERT embedding.
Dr. Ashraf, is this enough answer, or would
Well,
like to comment?
I am just trying to open directions for this research to be maybe considered by current researchers. Yes, it is open. Anybody can use whatever. You have used by GRU, you have used by LSTML, but people will say that maybe we go with CNN from the beginning because we know it is computationally less demanding, and it is proven for sentiment analysis given extremely good results. At least for Arabic, I am very well aware of so many ready embedding models that we can utilize. And I think Professor Samha, they have the Arabic. This is one of the very popular ones. In English, we have also similar, tons. So if you want to present some work, which is, we thank you for that, you need to put an argument for people, why should I take your model? Why, for example, I did not see a justification why I should use a concatenation layer in the model that you have developed. Most people, they are relying on one. You don't need max pooling, averaging, or taking the max, and so on. All these are experimental type of trials. And everyone, as you said, is up for choosing whatever model, but you have to provide the argument. Now, if you say fastText is very well used to serve rich morphological languages, such as Arabic. For English, that's a questionable. Maybe people would go the glove, Word2Vec, or they have a combination. But even all of these, that's what I'm saying. In the past 2 years, I have seen a big shift now towards BERT, Roberta, because they capture not only the syntax, but actually the semantics of the word. So if you have a word, I would like to know the context of that word. That's why I am just trying to draw your attention that if you would like to pursue research in this direction, then you have to provide solid argument for making people convinced why I should adopt the model that you are presenting. Nothing more, nothing less. Thank you, Professor Khalid, Professor Samha, and for the presenter. Thank you.
Thank you so much.
We still have time. So is there any questions, comments, inquiries for the research? Actually, discussion is fruitful and will enlighten us and will give us ideas. Maybe we can extend our research for easily for having another publications. So it's good that we get ideas. Okay, it's not all the paper are reviewed, the decision is already taken, and we just came to discuss and plan for the future. Okay, thank you very much. And we Elmo is another option as well. Dr. Ashraf, totally agree with you. This is from Minna Ishmeri. So would you like to comment, Minna, or just you drop this message and that's it?
Yes, Professor, I have very poor connection here.
Okay. Oh, this is...
I have shared the pre-recorded videos. You can share my screen here. If it is not working,
I think
we can play.
This is about the last one.
Yes, Professor.
This is about the suicidal risk identification social media. I will look. I think I have. You sent me. Did you send it to me?
Yes, Professor. Paper number 25.
Okay. Okay. So let me share the video if you have a problem in connection, and then you will be available for discussion, because the discussion is the important part.
Yes, Professor. Meanwhile, I'll try to share the screen, Professor. Shall I try?
Let me, as long as I have the paper, why not let us save the time? So it's this is a brief. Okay. So would like
Yes,
to go
yes.
live, or I use your recording?
Hello.
Dr. Ashok, I will start the video.
Yes.
Okay.
Yes.
Okay. Thank you.
Hi, everyone present here. I am Ashok Kumar, PhD Research Scholar in the Department of Information Science and Technology, Anna University, Chennai, India. I am here to present our work on suicidal risk identification in social media. I have carried out this work along with our co-authors Tina S. Truman and Avinash K. This is the outline of our program, where we will discuss about introduction, related works, research method, results and discussion, and then finally conclusion of our work. First, we'll discuss about introduction. As we know that suicide is rapidly increasing due to mental health problems such as anxiety and depression. Anxiety is a normal feeling or an emotion where the brain reacts to the stress and alerts to potential danger ahead. For instance, we may see that problem at work, making an important decision, and fear of an activity or a situation of an individual. Depression is associated with feeling of sadness, loss of interest, or anger of an individual. In particular, the World Health Organization indicated that suicide is the second largest cause of death worldwide among teenagers. Nowadays, online social media influence individual users to express their feelings or emotions in the form of posts or comments. These personal feelings help us to identify suicidal risk factors, namely suicidal ideations, suicidal indicators, suicidal behavior, suicidal attempt, and supportive. Next, we briefly discuss about each of these risk factors. First, suicidal ideation defines a suicidal thought of a user due to a loss of a strong relationship, a loss of a job, mental illness, substance abuse, or chronic disease. The suicidal behavior involves actively planning to commit suicide or involving in self-harm activities, using some blunt force violence or actions of death. Next, the suicidal attempt defines a complete attempt, or they might have changed their mind or writing a goodbye message. And the next one is a suicidal indicator, involves at-risk language from acute symptoms, or there will be engagement in a supportive manner. There is an history of divorce or chronic disease or sharing personal history. And finally, the supportive defines an active engagement without any history of the risk in the past or in the present language. So particularly, the participation of teenagers in social media games involves self-harm activities. Therefore, we need an automated system to identify suicidal risk factors in social media. Researchers used machine learning and deep learning methods to develop such kind of automated systems. So here, the traditional machine learning uses a bag of code features to perform such kind of task, where the deep learning model captures semantic context features in a fixed dimensions. And part of the deep learning models, there is an attention mechanism which has shown the promising results in NLP task. So where it captures the Key part of the sentence had to global context as well as in the local context. In this work, we propose a multiplicative attention-based bidirectional weighted recurrent unit to identify the suicidal risk factors in social media. So our contribution includes the following. Identifies the suicidal risk factors of online users and employs a multiplicative attention-based bidirectional gated recurrent unit. Our method outperforms the state-of-the models for suicidal risk and factor identification task. Next, we discuss about the related works. G. et al. Presented a supervised learning approach to identify suicidal ideation in user-generated context. The authors indicated that the XGBoost algorithm achieves better UAC core with a combination of statistical features, topic features, TF-ID features, and WhatsApp speech tag features, and linguistic word count, inquiry word count features. Then Cover et al. Studied a domain-specific learning framework to predict the suicidal risk factor of an individual. This study uses the suicidal ontology and medical knowledge base to detect suicidal thoughts. Next, Kumar et al. Explored suicidal identification using tweets. The authors indicate that the ensemble-based random forest algorithm achieves 99% accuracy for predicting the suicidal thought in tweets. Shawnee et al. Investigated deep learning architectures for suicidal ideation detection using tweets. Their study revealed that convolutional long short-term memory networks achieves 81.2% accuracy and 82.7 in F1 score. In summary, the most of the research is focused on suicidal ideation as a binary classification problem using user-generated content. However, there is no publicly available gold standard dataset except the Reddit suicide dataset. Here we discuss our research method. This is the general architecture of our program. Here we'll have the input data, and then embedding layer, and then bidirectional gated recurrent unit. Then we have the true dropout layer, and then there is a multiplicative attention layer. And we also apply the bias normalization flatten layer, and then finally we predict the suicidal risk factors using the softmax layer. So next we will discuss each of these important components briefly as follows. So this is the data set what we have used for our risk suicidal risk factor identification task. So where it has 500 users user post in different categories, what we discussed in the introduction, supportive, ideation, behavior, attempt, and indicator. So initially we remove the special characters and punctuations from the input text. We generate word vectors using the glowy word method for the training data. The word embedding captures the semantic and syntactic information in a general space. Specifically, the glowy method captures the word co-occurrence statistics, how that often a word occurs in the context window size. Next, we feed these generated word vectors to the recurrent neural networks. As we know that recurrent neural fails to remember long-term dependencies due to the vanishing gradient problem. To solve this, Harzer et al. Introduced the long short-term memory networks, and Cho et al. Introduced gated recurrent unit mechanism. So a long-term memory network has 3 input gates: input gate, output gate, and forget gate. Here the gated recurrent has two input gates, two gates. One is the reset gate and the update gate. These gates decides how much information to what information need to be stored or removed without memory blocks for predicting the output. Moreover, the gated recurrent unit learns only from the previous context. It doesn't focus on the feature context. To overcome this issue, Custard et al. Introduced bidirectional arguments to learn from the previous context and future context. Therefore, we use the bidirectional gated recurrent unit, which comprises of two layers of hidden nodes. The second layer uses the input sequence and sends it to the network. Next, we feed these hidden representations to the multiplicative attention mechanism. Because the gated recurrent unit cannot be selective attention to the key part of a text. Therefore, to address this issue, Bhattanav et al. Introduced an attention mechanism concept to capture the important part of a sentence. This concept has gained more popularity in the field of neural machine translations, computer vision, sentiment analysis, image generation, and image classification. Moreover, the attention mechanism concept is broadly addressed in two categories, namely global attention and local attention. The global attention weights all the input words, and the local attention weights only a subset of the input words in a sentence. The global attention is very expensive to translate longer sequences. Specifically, the additive and multiplicative attention concepts represent similar complexity. However, the multiplicative attention mechanism provides more space-efficient and fast computation. Therefore, we propose a multiplicative attention mechanism with attention weights to control the local context for the task of suicidal risk identification. It uses the inner product to compute the attention score in a faster and efficient way. So it is the mathematical representation of how the multiplicative attention mechanism is calculated. There is a hidden state representation from the bidirectional gated recurrent unit, and when attention energies were calculated, then these energies are passed to the softmax layer to obtain the final weighted output representations, where we will control the input output representation with attention weights. Then these attention context vectors passed to the fully connected layer, and then the dropout layer for regularizing the net, and finally a batch normalization and flattened layer to standardize the networks. Then finally the flattened input representation is passed to the softmax layer for predicting the suicidal risk factors of an individual. So results and discussion. These are the hyperparameters what we used for performing our experiment. Because the data is very small, so we cannot go beyond that. Otherwise the model starts to overfit. So this is the model performance what we have achieved, and here the compared with a base logistic corrections is the additive attention and multiplicative attentions. The multiplicative attention has scored better than the other models with the micro.
Workout resumed.
And finally, we conclude our work.
Workout paused.
We proposed a multiplicative attention gated recurrent unit to identify the suicidal risk factors of the individual. The proposed model achieves better performance than the other models in terms of the multiplication, multi-class classification problem. In future, we decided to study the suicidal risk identification plots on a gender and location in a large data set. These are the references what we have used for our research, and I welcome you from all. Any questions, comments, or concerns about our work for a better enhancement in the future? Thank you.
Thank you very much. And this is the last but not least. Is there any question? I thought that when we have a recording to be better than the connection, but I didn't feel any difference. Actually, please make sure next time when you do recording, you make it clear, because we have to listen to it, and it's difficult to follow.
Can you hear me? I have a question for the paper.
Yes,
okay.
yes.
So, as you discussing suicidal behavior, so what's about your, I mean, the column field of your data set? I mean, just you
data.
Yeah.
Yes, it's only the textual command which is written by the users. So that users were manually annotated by the psychologist. So the psychologist read those texts. This is retrieved from the Reddit post, and each text retrieved based on the suicidal type keywords. Then the psychologist and doctors together, they read each of those text and manually annotated based on the category. For each category, they have defined different types of aspects, whether it is falls into the suicidal ideation, whether it is falls into the suicidal attempt, whether it falls into the behavioral aspects. So there are certain aspects. I think the cow, you can refer the cow rater. He is the main contributor of this data set.
Yeah, I understand. So you may address the emotion. Yes. Under the emotion plus, you may define the level. For example, sad, then fear. So in this, or joy, happy, in this way.
Yes, it is a mix of sentences. The psychologists have framed a list of sentences for each category. For instance, if it is a behavior, I told you that there are, whether he is involved at active plan of suicidal thoughts. His actions might be getting into the self-harm activities. He's like to take the knife and cutting his hand, and he's showing, expressing these thoughts on the social media, or shows in the text-based messages. That can be identified by the psychologist. They were annotated. That is not only the and everything included, whether it's happiness, sadness, everything is included. Each category, there are a list of the documents that have been listed.
Okay, maybe you also address the time, because the suicidal ideation depends on time. When a user post maybe this is in mild category. After that, after few time or 1 month later, the user may be used severe category. When the user continuously post severe category post, then we can recommend that the user in suicidal thought by using
Yes,
time our
absolutely,
classification.
Yeah, time we have not considered. Yes, we will maybe considering in the future works the time based.
Okay, thank you.
Thank you.
Thank you very much. If there are any other questions, please.
I extremely sorry, Professor. My presentation, last minute only. Today I tried connect so many times, so I was disconnected for 10-20 minutes through connecting to the line. So it is was a low bandwidth. Sorry.
No problem. No, you don't have to apologize for something. It's not your mistake. But actually, at least the recording itself, it has noisy, a lot of noisy. This is was a problem to follow up your good paper.
Thank you.
Most welcome. Any other question, please? Okay, we are 10 minutes earlier, so we will have more break. Our break will, you see, I followed I use a clock that we have in the program web page, which shows the GMT time. So it's now 11:20 GMT time, and we should finish at 11:30. Then we take a break between 11:30 to 11:40. So 11:40 is the start of parallel session 2 and 3, one that chaired by myself and one chaired by Professor Samhan. So we will have longer break. You may do whatever you like. You may go also into any of the rooms to discuss whatever you like. It will be a good way for networking and discussion. I would like to stress that it is 20 minutes presentation. So, and since we have parallel presentation, since people can switch between them, so we will have strict on time when we finish and when we begin. So if you finish early, there will be silence until we start the next one, because actually I don't want someone who come and say I missed a presentation or a paper, because it is you started early. So we are going to synchronize the papers in terms of respecting times, same as big conferences that we all attend before. So put this in your mind. We are not in a hurry. We are not in a race. We are going to follow and respect the time we had. Okay. Thank you very much.
The breakout rooms are now open. Whenever you want to move from one room to another, you could just say leave room, not make sure that you leave room, not the meeting. When you say leave room, you'll be back in the main hall where you can select the other room that you would like to join. So as Dr. Khalid was saying, you can switch back and forth between sessions depending on what you're interested in. Thank you.
Thank you very much.